My name is Adam Koerner and I'm a PhD candidate in the Computational Neuroscience program at UC San Diego. I work in the lab of Virginia DeSauw conducting research on brain-computer interfaces, or BCIs. As a part of the Socrates Fellowship, I was paired with Tom McElfresh from Helix Charter High School. Tom teaches biology and physics to 10th through 12th graders. The main objective of this project is twofold: to teach students about how their brain is functionally organized, and to talk about how the brain communicates, as well as how we can access this information. We do this by using brain-computer interfaces, which, as the name implies, utilize the brain's natural signals to communicate directly with computers. Okay, essentially what they're doing is they're replacing some function of the peripheral nervous system. And we can give these students hands-on experience with simple BCI toys, simple BCI headsets, so that they can get a feel for what this technology really is and what we can do with it. And then we use that to kind of get them excited about how the brain works and how the brain communicates and all these things that your brain can do. And it's really just kind of a nice, fun, interactive way to introduce these concepts. And Listen basically consists of a combination of lectures, projects, worksheets, and experiments. They'll ideally be spending a good amount of time working with the toys and the headsets, as well as with the concepts we're trying to teach. Okay, we want them to have a very kind of interactive experience with this, to spend as much time playing with the toys and kind of getting a sense of, trying to get them to work and all that kind of thing, while at the same time thinking about these concepts, thinking about how it works, thinking about all the work that goes into figuring out this information. So the cool thing about this project is not only that it basically involves moving things with your mind, but it's also a project that's been developed as part of a collaboration between a grad student and a teacher. Right? It's based on cutting-edge research, but it's also gone through multiple iterations, multiple refinements and everything, so that we can know that the students are getting as much out of it as possible. So the thing is when you're using this lesson, you're not only getting one that's based on all this cool research that these students aren't going to otherwise be exposed to, but you're also getting a lesson that we've put a lot of care into developing, that we've really kind of sat down and figured out the best way to do this. Right? And I think it's a lot of fun for the students, and they get a lot out of it. It's a great way to learn the brain.